Hello, I am Colin Leatham. I'll be your professor today, and we're talking about properties of equality. Getting started here, talking about properties of equality, it's important to note that we're talking about equations and how to solve equations. So let's first off define what an equation is. And an equation is just a statement that sets two expressions equal. And that's very important. The thing that sets an expression different from an equation is that equal sign. When you're solving, you need to have an equal sign kind of at every step. And it's a good practice to have that equal sign, or basically rewrite your equation at every step. These first few properties, we're only dealing with essentially one-step equations, but it's good practice to get into. So first, we're going to be talking about the additional property of equality. Now, very simply, we're going to be adding or subtracting the same quantity from both sides of an equation. And when we do that, it keeps the equation valid. It's a lot like a teeter-totter. If you've got a teeter-totter, adding a value to one side but not the other makes it out of balance. Or if you subtract something from the other side, or one side without subtracting the same thing from the other, it also gets out of balance. But if you're doing the same thing to both sides, your equation stays valid. So let's show you what this looks like. Let's start with the example of x plus 6 is equal to 5. And what we're going to do is we are going to subtract the same quantity from both sides. Now, what we're doing here is you always want to, whatever you're doing to your variable, you're going to do the opposite. So here, what our original equation states is we're adding 6 to x plus 6. So instead, to undo this, to isolate our variable, we're going to subtract 6 from both sides of our equation. And when I do that, well, 6 minus 6 is 0. So I'm just going to have x is equal to -1. So that's all we needed to do to solve that first equation. Let's do it again. Only this time, instead of adding something, I'm going to do, how about I do y minus 5 is equal to 12. Oops, let me move this down. Y minus 5 equals 12. I'm once again going to do the opposite. Our goal here, the technical term for what we're doing is we're isolating the variable. We're going to isolate the variable term. So in order to get this y all by itself on one side of my equation, I'm going to go ahead and, well, since this is minus 5, I'm going to do the opposite. I'm going to add 5. But what we do to one side, we do the same thing to the other, always. So now, since I've got y minus 5 plus 5, well, the 5's just cancel out. This is just going to be y alone by itself on that left side of the equation. On the right side, 12 plus 5 is going to be 17, and we've solved it. Now, I want you to note that this doesn't always have to be moving this term here on the left over to the right. We're not always just automatically adding or subtracting this term over here. If I've got my variable on the right, we're going to take whatever's attached to that, whatever we're doing over there. So say, for example, I've got -7 is equal to m minus 6. If I were to take both sides now, if I were to add or subtract something, it's not going to be that 7. I want to look at whatever side my variable is on and see what I have to do to get that variable by itself. I would need to add 6 over here on the right, which means whatever I do on one side, I've got to do the same thing on the left. I'm adding the same quantity on both left and right, but here on the right, I'm just left with m, because negative 6 plus 6 is 0, and m plus 0 is just m. Negative 7 plus 6 would be a negative 1. So this is how we isolate the variable. So we're paying attention not to what side we're on. We want to pay attention to where the variable is. Where the variable is determines which constant we're going to add or subtract. The next thing we're going to talk about is the multiplication property of equality. Now, the multiplication property says something fairly similar to our addition property. If you multiply or divide both sides of an equation, that's going to keep that equation valid. So as long as you multiply or divide both sides by the same quantity, your equation remains in balance. So let's start off by giving us another example. Let's say we've got something like negative 4a is equal to 24. What we're going to do is we're going to divide both sides. And when we do this, we always are going to include that sign. Now, if you think about that, that will make a good deal of sense. Anything divided by its own sign, negative divided by negative is positive, positive divided by positive is positive. So if I take both sides and I divide by the thing, including its own signs, I'm going to divide both sides here by negative 4. Negative 4 divided by negative 4 is going to be 1. Well, and I'll have that a left over. 24 divided by negative 4 is going to be negative 6. And we're done. And if we think about this, this will make some sense. If I think about what that original equation was, when I check that, it was negative 4 times a is equal to 24. But now if I know that a is equal to negative 6, oh, negative 4 times negative 6 is equal to 24. That looks like good math. 24 is equal to 24. That answer checks out. So here in our little thought bubble, it does check out. I realize that a lot of folks are going to be able to do this in your head. If you're new to this, please write these steps down. It's good to get the reflex of doing this on paper, because when you practice that, it's building up muscle memory, because sooner or later you're going to hit equations where you're not going to be able to see the end from the beginning. So it's a good thing to practice these kind of as they are. Anyway, let's practice a few more of these. And this can be anything as simple as like, 3t is equal to 18. Oops, that's an equals. My markers are a little fat here. Okay, let's take both sides and divide by 3. Okay, when I do that, 3 divided by 3 is 1, so I've just got t is equal to 6. I seem to like 6s today. Yeah. Now, one of the things that you're going to also notice is you might end up with some equations where instead of multiplying your variable, you're dividing it. Well, think about doing the opposite again. So say I've got something like, y over 5 is equal to negative 2. Thinking about doing the opposite, if I'm dividing by 5, the opposite of dividing by 5 would be multiplying by 5. So here, we're going to take both sides of our equation and we're going to multiply by that denominator. And essentially, all we're doing is multiplication. It looks a little different with some variables in the mix, but this is just fraction multiplication. 5 over 1 times y over 5, the 5's cancel out. So I've just got 1 times y is y over 1, which is just going to be y. 5 times negative 2 is going to be negative 10. And we're done. And this works all the time. If I've got something like n over 4 is equal to 7, I could take both sides and multiply by that denominator. Multiply both sides by 4. And these are just going to cancel right out. I'll just be left with my denominator here, or my denominator. I'll just be left with my variable here. 4 times 7 is 28. One other fun little trick that's a good thing to practice. Oops, I didn't manage to smudge my paper here. Is when you have a fraction as a coefficient. So say we've got something like 2/3 m is equal to 12. What we're going to do is you're going to multiply by the reciprocal. Now, remember, the reciprocal is just when you flip a fraction. If I take any fraction and multiply it by its reciprocal, the answer is going to be 1. So if I were to take this side of the equation and I were to multiply this by 3 over 2, notice that the 3's will cancel top to bottom and the 2's would cancel. So I'd just be left with 1m. But whatever I do on one side, I have to do the exact same thing on the other. So we're here on the left, I'm just left with an m. We've got a little bit more complicated thing to deal with over here because I've got this 3/2 times 12. Now, if it helps, put that whole number over 1. And I always like to tell people, reduce first, multiply last. If you're reducing at the end, you are making your life harder. 2 goes into 12 6 times. Now I'll just multiply straight across. 3 times 6 is 18, and 1 times 1 would be 1. So our answer here is just m is equal to 18. All right, I think I'll leave you with that for now, and I will see you in the next recording.